In this video, we're going to do a little proof about eigenvectors. Here's the problem. Given that x is an eigenvector of the invertible matrix A with eigenvalue 7, show that x is an eigenvector of the matrix A inverse. Well, first thing we'll do is we'll write down the definition of an eigenvector. We know x is an eigenvector of A, meaning ax is equal to lambda x. So I'm going to say that's just the definition. We're told that the eigenvalue is 7, so we could write ax equals 7x if we want to be more specific. Now we're told that the matrix A is invertible, which allows us to multiply on the left by A inverse. And I'm going to put some brackets on the right side just to make it a little bit easier to read. So A inverse times AX must be equal to A inverse times 7x. The justification here, I'm going to note that A is invertible. That's why we're sure that A inverse exists and that this is a valid step. Now looking at the left side, A inverse times A is equal to the identity matrix for any matrix A. So we're safe to write Ix on the left-hand side. And on the right-hand side, this constant 7 can be brought out to the front. So we can write 7 times A inverse times X. What we've used here is one of the properties of matrices. Now moving from this expression to this expression down here is a potential source of confusion. So if you like, we could do a little bit of scribbling over on the side just to convince ourselves that this is valid. Let's just do an example. Let's say that A inverse is a 2 by 2 matrix. Maybe we'll just call it A, B, C, D. And X would therefore be a vector with 2 components. So let's maybe call it X1, X2. And let's just check that if we were to take A inverse times 7x, we'd have the matrix ABCD times the vector 7x, which would look like 7x1, 7x2. If we actually did that matrix multiplication, the A would multiply with the 7x1, so I'm going to write that 7ax1 plus 7bx2. In the second component, we'd have 7cx1 plus 7dx2. And the idea is that each of these terms here in each of the components has a 7 in it. So that 7 could be pulled out in front. We could write 7 times the vector ax1 plus bx2, cx1 plus dx2. And this vector that we've got right here, that is the same thing as having the matrix ABCD times the vector x1, x2. So that really is 7 times A inverse times x. Now, we've chosen in this particular case for A inverse to be a 2 by 2 matrix. We weren't exactly told that in the problem, so this is not quite a full proof of this property. It's more just an example to convince ourselves that this general property holds. Now returning to our proof, I times any matrix or any vector gives us that original vector back, so we've really just got x on the left-hand side. Now it's valid to multiply both sides of this equation here by the number 1/7. We're doing that just to eliminate the 7 from the right side, so multiplying through by 1/7 we get A inverse times x on the right. And if we write this the other way around, A inverse x equals 1/7 times x, this starts to look a little bit more familiar. So we've now got the pattern of a matrix times a vector equaling a constant times that original vector. So this tells us that x is indeed an eigenvector of A inverse. And if we want to be a little bit more specific, we can say corresponding to the eigenvalue lambda equals 1/7.